right. I think there we go. All right, now we're good. All right, we've got an assortment of things to do today. We got the printer running over here. It is idling for the minute. We're going to attempt something on it that you should be able to do. My particular one may have some issues because of the sonic pad not doing exactly what I want it to do, but it'll be fine. We'll look at that in a minute. In the meantime, I've got a couple of things to look at. Then we'll go into some ideas on how you can do two-color printing, even if you have a regular Ender 3 nothing, Ender 3 base model printer or any kind of printer like that. There are ways that you can do two-color printing. They're not or actually multicolor. It doesn't have to be two colors, but they're not the ones where you can create a multicolor object just in any pattern you want. But there are a couple of things you can do to get color into your prints without just painting them. Speaking of painting them, I do have a product over here I was going to show off, and a couple of filament types and a couple of things. So let's go over here. Actually, now that I think about it, we probably don't have that set up, do we? Oh, yeah, we do. It's just crooked. There we go. Let's look at which way makes the most sense. I think that way does. Let's focus on it a little bit. All right. So, first, here I printed this. This is some carbon fiber PETG. This is a good material for if you are trying to hide your layer lines. It's also a strong-ish material. This particular one, just because it has carbon fiber in it, doesn't necessarily make it a strong material, because the carbon fiber could be like carbon fiber dust or carbon fiber powder or something like that. And that might help some with creating the part in a way that it doesn't warp as bad. So some materials that are prone to warping might have some carbon fiber dust or carbon fiber powder that's in it that kind of helps it not warp, gives it a nice surface finish. So this one actually has milled carbon fiber, which is better. You're not going to find any that I know of materials that are going to print on a regular base FDM style printer at a lower temperature that have like really long pieces of carbon fiber in them, and really long is like 1 millimeter. But this one does have, it doesn't say the length of the parts of carbon fiber in here. It just says that this is milled carbon fiber, not powder or dust. And so this one actually probably does provide a little extra strength, having those carbon fiber, I'll call them strands, but they're probably still very, very tiny in it. The main thing I like for using carbon fiber materials is that they typically give you a much better surface finish. You can see the layer lines. Yeah, you can see the layer lines. I had to look up close on this one because I printed it at 0.3 millimeters, just trying to get it done faster. But without looking very close at it, you can't really see the layer lines. Now, it probably did add a little bit of strength to it. It is PETG, so it does print at a higher temperature. This particular one I printed at, the range says, let's see if we can get a little closer to that. The range on it says 240 to 265. I probably printed it at 245, which is really at the upper end of a regular Ender 3 with a Bowden tube that goes down into the hot end. At that temperature, you're starting to break down the Bowden tube itself, the Teflon that it's made of, and you'll eventually have failures in that tube. You can print at that temperature, 245 or so, for a while, and then you take the tube out, replace it, or cut the end off and put it back, whatever. But remember, we've changed our printer over here to have an all-metal hot end, so I can print up to 300 or so. At that point, I start running into issues with the thermistor not tracking, it's not calibrated for those higher temperatures. It'll become nonlinear and it won't report temperature accurately. But the hot end itself will be fine. So I printed this probably at 245. The bed temperature is a little higher. These are fine bed temperatures for an Ender 3 style printer. You can go up to around 80, maybe 85. It does take longer to start getting up to those higher temperatures, but 60 is not a big deal. That's what I printed at. I did use some glue stick because it is PETG. This is the one I used. If you do PETG directly on a glass surface, I have a textured glass, so it's not just plain glass, but if you did a plain glass, then it can stick to it really tightly, and to the point that you'll break the glass getting it off of there. So it's a good idea in general to use some kind of release agent. So not trying to make it stick more, but to provide some kind of barrier between the PETG and the glass. Now, if you have other materials than glass, other than glass, then it's probably not a big deal. So I did use this. I used it says the fan off or low. When I do PETG, whatever it is, this is carbon fiber PETG or just straight PETG or whatever, I usually use 50% fan. So no fan on the first 2 layers and then 50% after that. And it usually works decently well. No fan at all, it'll print and it'll be really strong. Like the layers will be bonded together pretty well. But it'll be a little runny, gooey, stringy. 100% fan, it'll look really nice, but it'll be really brittle. There will almost be no layer adhesion. So I do 50%, and it's pretty good. It flexes without cracking, so that's good. So that's a material that, without any changes, you can print. Assuming you can get it to print at the lower temperature, you can print that on an Ender 3. You probably do want a hardened nozzle because it will eat up a brass nozzle really quickly. Even if it's the carbon fiber dust or powder, it'll eat it up pretty badly. So you do want a hardened nozzle. This one does say consider hardened nozzle, which this printer does have hardened steel, all metal hot end, so it had no problem printing it. But on your basic Ender 3, you would at least want to change out to have a hardened steel nozzle, which is pretty easy to change. So that material might be one that you look at. It is a little more expensive. You know, it can be 1.5 to 2 times the price of just plain PETG. I would not get it for the increased strength unless you knew you were getting carbon fiber strands, like chopped or milled strands. And again, strand is really short steel, but not carbon fiber powder or dust. So if the specifications of the roll said that it was milled or something along those lines, then it will actually add strength a little bit. Maybe not a lot, but it will add some strength. If you want, there are some carbon fiber infused nylons and more exotic type materials that actually do add a lot of strength, but they probably won't print on a basic Ender 3 style printer. In fact, at school we have a Mark forged printer that it prints a material called onyx, which is nylon with carbon fiber chopped in it. So that material by itself is really good, but then it can also inlay like continuous strings, like meters of carbon fiber or Kevlar or fiberglass strands, and so it can make some really strong parts. It still has the issues with the layer adhesion. It doesn't make the carbon fiber strands, you know, go across layers. They're all in a layer. So you do have to think about how the part's going to be loaded if you're trying to get strength out of it by adding those strands. Here, I think this adds a little bit of strength. I haven't actually done any tensile test or anything on it. It does say, let's see. Actually, this does not say. It says they're not brittle is all it says, but it doesn't actually say that this adds any strength. And that's typically true at these lower temperature and carbon fiber where it's really tiny carbon fiber. Even the milled stuff is still really small. It's probably not going to add a lot of strength, but it'll help with warping, prevent warping, and it will help with just the finish. The finish looks really nice. So that is an option. Something like this. I don't know if this company Atomic even makes this stuff anymore. This is an old sample. Looks like from 2019 apparently. So, and I didn't do anything to it. It printed fine. PETG does not typically absorb moisture very rapidly at all. So PETG It just sat in this bag with, there's a little tiny desiccant pack in there, it looks like. Can't even find it now. Yeah, right there. There's a little tiny desiccant pack. And it was in a Ziploc since 2019, and it printed fine. I didn't do anything to it. So that's carbon fiber infused. Infused is not the right word, but chopped up carbon fiber pieces, tiny pieces, in PETG. They also have it in other materials. I think there's even a carbon fiber PLA. That one's probably pretty brittle. I would, if I were going to do a carbon fiber material, I would probably get a PETG with carbon fiber in it, and it's probably going to be in the $30 to $40 a kilogram range for you. Do be careful, because you'll see some cheap ones, like $20 or whatever, and what you're actually buying is a half kilogram roll of that. So be careful to make sure that you're getting the full kilogram if that's what you're expecting. So that's a good material to work with if you're interested in surface finish, low warping, and maybe a slight bump in strength. I'd have to do some actual testing to see if there's any real increase in strength or not. There might be some flexural strength increase, maybe, but the strands are so tiny that I doubt they're doing a whole lot. Here, some finishing techniques. So here's Skeletor. He's 3D printed, FDM. You can probably pick up some layers somewhere in there. Looks like you can see some right there. So I don't remember where this model came from. I'm sure it came from Thingiverse or something. It was free. I didn't buy it or didn't make it. What he's got on him though, so he looks like a little bronze statue or something. He has been printed, and then a relatively heavy coat of high build primer like Rust-Oleum or something you would get from an AutoZone type store, maybe Walmart, but the automotive high build primer to kind of fill in some layer lines. Then he was sprayed with a gloss black. That's important here. The layer line issue is probably kind of important because of the process that this is. You're trying to eliminate the layer line, so the primer's probably good. I don't think I'd go straight to the gloss black, but you could. So the gloss black is important to give it kind of shiny metallic type of thing. And then how you get the color on there is with something like this. So this is Rub and Buff. See if I can get them in there. I have 3 of them. There's actually several, maybe 6 different colors of Rub and Buff. I know you can get it from Hobby Lobby. I don't know if there's other. You can get it online. Obviously, you can buy it. It's a little bit expensive, but it lasts forever. Like you'll almost never run out of it because you use such a tiny amount when you're actually doing something with it. But the idea is that it's basically like a tinted wax. So you paint your gloss black, so it's all gloss shiny black. Let that dry completely, and then you take a super tiny amount of this and you rub it on and polish it off. And it doesn't, once you've got it embedded in there, you know, it doesn't rub off on you or anything. Doesn't come off. You can handle it, and it'll be fine. But let's see, I can maybe, if I've opened this one. Yeah, I've opened that one. So let's get some of this. This is the silver leaf. Let's just get a little bit of it on here. So a super tiny amount. And we'll put it on his face. And so you just kind of put it on there. My Q-tip's falling apart. And then you just kind of rub it out. I actually might have put too much on there. You're trying to rub, see now some of it's coming off. You're trying to kind of rub it out to where it stays in just a few places. So you have to pick how much you want to rub and where you want to rub. But you can tint. Maybe we put some down here. You can tint parts this way. It does need to be, or well, it doesn't need to be, but it works best on a gloss surface, and it doesn't have to be gloss black. You can get different effects by using a different base color. But there you can kind of see now he's got a silvery face. And like I said, there's several different colors of this stuff. It's kind of expensive. It seems like it's like $5 or $6 for one tiny little tube, but like I said, you'll never run out of the stuff unless you're making thousands of pieces out of it, because this amount that I put on here was actually too much for what we were doing there. And that was just dabbing the end into the tube. That was all it was. So that's a good way to get a different kind of finish on your parts if you want something that looks kind of like a cast piece of metal. There are a lot of other things like that. There's some patina sprays where you can spray on a paint that has metallic powder in it, and then add some chemicals to make it actually patina, like the Statue of Liberty. You know, it's actually copper, but it doesn't look copper colored at all. It's all green. It's this patina on there. And so you can create different patinas, different finishes. You can create these metallic finishes with rub and buff. A lot of different properties out there, or materials out there, that you can create a different look. You can actually electroplate parts. I have not done that. That does require some different chemicals. You have to have electroplating solution and things. You can get a starter kit, I don't know, $70 or something like that. But if you're interested in electroplating, there are some really good examples, obviously on YouTube, where people have printed, FDM printed, usually it's FDM, sometimes they do resin prints, but FDM printed, and then a lot of sanding to get the part smooth, because if you're electroplating, then you're depositing super thin layers of metal, actual metal, onto the part, and it's gonna, any layer lines are definitely going to show up, and you'll lose the effect of it being shiny metal. But you can find plenty of really good examples of electroplated plastic parts that people did at home. You do have to have a power supply and the correct chemicals and things like that. So it's not a simple process, and it's very time consuming on the sanding side, but you can do it. This gives you a similar effect at much faster. Also, I wonder if I could find that. A cheaper way and much faster way to get a chrome type finish is, let me look and see if I can find this pin. These little pins. Let's see if I can get him out of the way. Here we go. Liquid chrome from Molotov, MOLOTOW. These, and they come in different sizes. These do look very chrome-like. Again, it's dependent on the base surface. So if your base surface is very lumpy, like a bunch of layer lines, then it won't give you quite the effect. But this stuff actually does a good job of giving you a chrome-like finish if you can get the base surface pretty smooth. And you just paint it on. It's just a paint pen. So that is another relatively easy way, without having to go the electroplating way, to get a convincing chrome finish on a part. So those are a couple of things you can do to make your parts look metal. They won't be metal, but they'll kind of have a metallic finish to them. There's some other paints and other things that we could talk about if we really wanted to, but these are the most accessible. Rub and buff and Molotov liquid chrome pins. Those are the easiest ways that you don't have to buy a bunch of chemicals, or you don't have to do a lot of stuff like that, special airbrush paints. And you know, these is a paint pen or a little tube of wax. So those are pretty straightforward, and you get decent results. I don't know if I can actually, I probably can't put this on top of here because it's a wax, and I doubt it would stick to it. Maybe we'll try and see what happens. I assume it's going to make a giant mess, but let's see. Maybe we can put some chrome. We'll put it on the back in case it does make a giant mess. We'll do something right here. So it's a little paint pen, and you just paint it on. It does take a significant amount of time to dry. So, and if you can get the paint to kind of go on thick, the chrome paint, then it will self-level and give a pretty good effect. On here, yeah, on top of the wax and everything, it's not giving a very good. It's basically looking kind of like white, gray color. because it's not really flowing the way you would want it to. Maybe I can get some more to come out. It will. It does seem to stick on there, which is good. But it's not giving the chrome effect that it normally does on that. I didn't think it would, but I kind of wanted to try and see if it would. We'll let that sit and see if it levels. I think it just doesn't work very well over the top of the wax rub and buff. But we'll come back to that and see what it does look like. All right. See, those are those things. Let's get that out of the way. What else do I have over here? Oh, this is a handy thing to have if you're not using the little isopropyl alcohol wipe pads that are individually wrapped. Then a little spray bottle like this with isopropyl alcohol in it is a handy way to just spray off your bed and wipe it clean. Some kind of microfiber cloth or whatever. That's a good thing to have nearby. I actually like that more than the little pads, but I have both. Let's see. I think this. So this is an older one, but these are handheld 3D printer pins. So looks like we have a little slowdown in the stream, but we'll carry on. It hadn't crashed. But what's inside? These are not terribly expensive. You can usually find one for $20 or $30, and they're relatively handy. I don't ever use them for like making parts from. Some people, you can find some really fancy parts that have been made just with the 3D pin, and you're the controller. But what they are good for is patching up parts, and they're good for creating your own stuff too. But that's, yeah, I guess that's more of an art thing than actually functional. But they will take usually filament from PLA to ABS, maybe PETG. I haven't tried, but they probably get hot enough. They actually have a nozzle down here, so a little coil heater here, usually a couple of buttons for forwards and backwards. This one has a screen on setting your temperature and feed rate, and you use it. Well, you don't want to use it like that because that does get really hot. You use it like a pin, and you can weld parts together with filament. So you can add filament to a gap. You can repair parts. I saw in Discord a couple of, maybe it was last week, somebody had a 20-something hour, 12-hour print, a really long print, and it failed in the last couple of minutes, last half hour or whatever. You can save those prints, so I don't know if I would use one of these to save it or not, but what I would do is you measure, if you don't have power resume, like your power failure resume printer option. So sometimes you do, sometimes you don't. It depends on if you've turned it on and if your printer is capable of it. But so sometimes power failures can be recovered, but sometimes it's something like the filament ran out and that there's not a filament sensor or whatever, or it just started stringing, or it clogged, or whatever. So assuming you can't resume and just continue the print, then what you do is you measure how far you did complete, and then you take your same exact model and in your slicer drop it that far down below the bed and only print the remainder, and then you glue the parts together, or maybe you weld them back together with a 3D printing pen. So these are kind of handy for patching up things, welding things. You can technically create stuff with them. I don't ever do that, but it is possible. But if you start getting into, you're making big, like maybe you're making helmets, and so each print is 2 days, and any failure is going to cost you a lot of time. So these can at least recover some of those failures, and maybe you have some post-processing work to clean up the seam or whatever, but it will save a lot of time or just a complete restart. So these are kind of handy for stuff like that if you're making bigger parts, or if you just want to make some organic shapes that are hard to model. These are kind of, I don't know if this particular brand is good. It does work. I don't even know if this brand still exists. This pen is relatively old. Somewhere, I don't think it's here. I think it's in my office. I have like the original, the 3D Doodler. I don't remember the name of it. The Kickstarter one from like 5 years ago or 6 years ago. And it still works. So there's not a whole lot that can go wrong with these. They basically heat up and extrude and retract material. And that's kind of all they do. So they're kind of handy to have around if you didn't know about those. You can, if it fits your workflow, you can add one pretty easily. All right, I think what we're going to do now is something I've been having trouble with on the printer. So again, this printer is running Klipper, and so Klipper is great, and it allows you to have a lot of control over every little nuanced piece of your firmware and control of the printer and everything. And it adds some new functionality like input shaping. But I'm having issues with a particular macro that I want to use. So what I actually want to do is I want to be in Cura. So let's open Cura. And I want to print this. So I want to print this little coin I made in Tinkercad. We'll actually look at Tinkercad if we have time, because it is an easy way to quickly mock out stuff and test it out. So I made this thing in Tinkercad, and what I want it to be is I want it to be 2 colors. So there are a lot of different ways to get multicolor prints. You know, newer printers like the Bamboo, and there's a new Creality printer. They cost more, but they can even have multiple spools of filament that feed into them. But that takes a control system, and you know, it takes some special slicing to know which filament to send at what time. It wastes some material on purging between different colors and all that kind of stuff. But I don't have that. I do have a multi-material upgrade unit thing for the Prusa that we might look at. It's not very popular these days. They have better ways of doing multi-material, but I do have one over there. And I have a palette, which is an accessory that you add to any printer, any FDM printer, and it will take multiple filament strands in and chop them up and weld them together into one long multicolored filament that as you print, the correct color will come out of the nozzle at the correct time and color your print. And so those are multicolor or multi-material. They don't have to be just be different colors. They can be different materials. Ways of getting multicolor prints. Obviously you can paint things, but what I want is I want something pretty simple. I just want the bottom of this coin to be one color and all the raised features to be another color. So you can do that on any FDM printer. One nozzle, nothing fancy, no automatic filament changing systems or anything. You can just manually do it. And so the process is you build your model. You probably should build your model with the thinking of what are you going to do layer wise, so that you know kind of like, okay, I'm going to make 6 layers here and then change filaments. So if I'm going to make 6 layers and they're going to be 0.2 millimeters, then I need to make it 1.2 millimeters thick before I change layers. So you should design your parts with the idea of making them end at a certain layer easily versus having some partial layer or whatever. But that's more on the design side of things. You could just make a part, and then Cura, if you have your post-processing. So I believe this is baked into Cura. I don't think you even have to add it in. I think post-processing is in there. This part for calibration would not be in there by default, but this I believe is in your extensions. Let's look at the thing so you can actually see what we're doing here. So I've got this. I guess if you weren't seeing the coin that I was talking about, here's a little coin. Extensions, yeah, you can see that. Post-processing, modify G-code. So remember, the whole point of the slicer is to take your 3D model, build it into, or cut it into slices, and describe those slices in G-code. And then the G-code is actually what controls the printer. or tells the printer what to do. So I'm going to modify that G code. And there's a lot of little scripts that are built in, a lot of these different ones. But there is one that's filament change. And it gives you this set of options over here. This M600 command is the filament change G code command. Now, if you're running Klipper, you may not have M600 because remember, Klipper doesn't use the full Marlin set. Marlin is the firmware that most of these FDM printers come shipped with. Although it's starting to migrate to where a lot of the newer printers are coming with Klipper or something like Klipper installed. But Marlin M600 may not be in your configuration file for your Klipper profile. Now, you can add it and create your own, but it should be, if you just have a regular ender running a regular set of Marlin firmware, then M600 should be included. And M600 specifically does several things with the intent that you have printed some amount of color. Filament doesn't have to be a color change, it's just a filament change. So you've printed some amount of filament, some number of layers, and at a certain layer, here it says layer 1, then you want it to pause, move the print head out of the way, wait for a filament change to happen. So you go take the old filament out, put some new filament in. You do have to make sure that you purge the new filament through, because it's particularly if your colors are, a really dark color and really light color, and the light color comes after the dark one, little bits of filament will remain in that hot end for quite a while, and they will tint the new color. So if the new color is lighter, then it might take a while for it to completely go to the color you want. Like if you printed red and you want to print white on top of that, you'd get a significant amount of pink in between before the white actually purged out all the red. So you purge it out. I usually just push it through manually. And then you hit resume and it goes back to printing. So that's assuming you have a regular printer, not doing Klipper, then that's pretty automatic. You just tell it what layer. So you go over here, you slice your part with all your settings you want. You preview it, and then you use your slider over here to see, well, I want all of these layers to be one color. There's the top, I want that. So it looks like right there on layer 11, it starts printing just the raised reliefs material that I want to be a new color. I would probably go one extra layer just to be sure. So there's layer 12. And at layer 12, I would go in here and say, okay, well, I've actually got two of these in here now. Let's remove one of them. Layer 12. And I think you would probably uncheck this. I think this is unchecked by default. And it gives you these options. I was trying to force Klipper to do what it was supposed to do with using the firmware configuration. It did not work the last time I tried it, so we'll have to do something different. But you've got probably this option. I'll leave it this way. And then close. And now when you slice it, you can't slice. You have to reslice it anytime you change your G-code modifiers. So we reslice it. And let's, instead of uploading it, let's save it to disk so that we can look at it. So let's it's got the, so Tinkercad gives it really strange names all the time. So let's give it something there's a multicolor coin already. Let's call this number 2. And then let's actually go look at the file. So I'm going to open it with Notepad++. Got a bunch of them already open. Let's close all these. Okay, so somewhere around layer 12, so this is all the G code that's being sent to the printer. This is what we saved on the SD card that your printer would read and start printing. So there's all kind of commands in here. I don't want to move them around, but there are commands, and it will have layers. Now, it will probably be off a little bit because Cura starts counting. Go back to Cura. Cura starts counting at layer 1. and Marlin actually starts counting at layer 0. So it'll probably be off by 1. But let's go look for, actually let's just look for M600. So there it is. So that it entered these 3 lines. So that's all it did. So you could do this manually if you wanted to. You could just go find the layer in your G code, type in M600 right before the layer that you want it to change on, and it should take over. Klipper's not doing that because it does, the version of Klipper that I'm using came from the Sonic pad. So whatever they did is, it does have an implementation of M600, and it does stop the printer at the right layer, and I can change out the filament, but it won't let me resume the print. So what I'm going to do, going to try to do, is, I know that, let's go look at Klipper. So here's Klipper, and I've got my configuration file, my printer configuration file, and I know that I'm pretty sure I have a pause command. Yes, there's resume, and there's pause. So I already have a pause command, and I think I'm just going to put pause in here. So I'm going to manually, wherever it put the M600, I'm just going to tell it to pause. And I'm going to save that. I'll save it as, let's put Klipper on there so we know that this is one for Klipper. And let's just try this out and see if that will fix my problem. Because I have a G-code pause command. I know I can resume from a pause command. So I think this will work, but I don't know. Where did I save it as? It's on the desktop. All right. So let's go back, close this down, go over here. We will go to Files, and we will add a file, upload a file, and we will find the file on the desktop. Where did it go? I thought I saved it on the desktop, but it doesn't seem to be there. Let's see. You know what? I might have saved it with the wrong extension on it. So let's try that again. File, save as. Yeah, see, a lot of times when it says normal text file, it'll actually make this into a .txt. So let's do all types, and we'll manually type in G-code. Force it to make the G-code extension on there. Now it's on there. So that's what it was. So the extension on there was not .G-code when I saved it from Notepad. Now it is. All right, so we'll open that. So it uploads it over here. Don't know why it's taking that long, because it's not a big file, but there it is. And we will go to print. I do have filament. I have some blue filament loaded, so that's fine. I don't actually care what colors it is, what colors it will be. Not sure why it started at 69% though. Oh, I think, that's interesting. It's actually resuming the print that I tried to do that I said it wouldn't resume. That's really strange. So maybe it will resume, I just don't use the resume command. But now we gotta start over. So, that's interesting. Let's go back to our files and try to print the one we just started. All right, so now it's starting from scratch. Let's see if you can see what it's doing over here. Let's get it. There it is. Oh, it's got to heat up a little bit. It's about ready. It's got to go from up to 50 degrees on the bed, and I've got it at 200 for the extruder. Maybe I'll take that chance to wipe it down a little bit. It's actually too hot, so it's got to cool down a tiny bit. All right, there it goes. Now, this print is not going to look super nice because I'm printing it extra fast just to try and get the timing of the filament change correct. So it's not going to be a super great print. I'm currently printing it at 200% speed, which it was already at 70 or so, so it might be going a little bit fast for making nice extrusions. A little bit high. I'm going to lower it down. So one of the things you can do in some of your printers on the little control panel that would be somewhere over here, there's a thing called baby stepping. In Klipper, it's on the control panel. I don't even have a screen over here anymore. And what baby stepping does is it lets you adjust the Z height while you're printing. And that's a nice feature to have. Trying to get that first layer just right. It looks like it's good enough for now. So it's not going too fast because normally your first layer is printed at 50% of your speed anyway, actually your first couple of layers, and maybe your outer walls are printed slower than your base speed. So you might be printing something and you have Cura set to 70 millimeters a second or 100 millimeters per second, and it never seems to get all that fast. It's because a lot of the base layers and outer walls are set to a certain percentage of your base speed, and it's usually half or smaller. So that's why you'll see your first layers and your outer walls are usually slower no matter what speed you set it at, because they're a fraction of your actual speed. So it's doing okay right now, but then it's doing top and bottom layers of 2 and a relatively small 30% infill. So it's working on layer 2 right now. I guess I've got some red filament up here, so that we'll probably use that for the other layer. So it'll be red and blue. One thing you have to be careful of, I don't know that the pause command does this, but if it turns the stepper motors off, then you can easily move stuff around and it will lose track of where it's at. So I don't think pause does that, but there are other ways you could make it stop printing where it does release the stepper motors and they're not holding their position. In that case, you would have issues on ever getting it back to where it's supposed to be. See how Skeletor is doing. Yeah, the liquid chrome just doesn't do very well on top of the rub and buff. It actually doesn't even look as good as his rub and buff on his face. So I wouldn't do that. Alright, so now we're going closer to, let's see, what speed are we at now? Now we're doing in the 140 millimeters a second range, but then it slows down on the outer perimeter again. But I'm not too worried about the surface finish. I just want to get to the layer where I want it to change. And then if we get it working, then I can change it down to a reasonable speed where it does print nicely. It doesn't look that bad, even for printing faster than I normally would. Let's see. It's currently on layer 80. Oh no, not 80. 8. And we wanted to change it. I don't know if it's going to change at 11 or 12. I think the count here, I didn't see if this counted at starting at 0 or 1 on the Klipper screen over here. So now it's doing layer 9. Oh no, our internet almost dropped out on us. But we came back. Nothing happened in the little internet outage. We're still on layer 9. Oh, now we're on layer 10. So I don't know. I think this might be the last layer. I don't know. It looks like there might be one more layer before it changes. And again, I've only got 2 top layers, so that is usually not enough, particularly when you have a low infill, because the layers have to bridge across all your infill patterns. Like if we go back to Cura while we're waiting on it. So, you know, I've got this really sparse infill, and this layer right here has to bridge across all of these gaps in your infill. And if you only do 2 layers, now mine are, no, actually I'm doing 0.2 millimeter layers, so they're the regular thickness. Then that top layer is going to have little divots in it, little indentions, because the filament's going to sag down. So if you have low infill, then you at least want 3 layers. I only did 2 just to speed things up, but you probably should do a 3rd one to try and level out that top layer. Alright, so we're on layer 11, so any minute now, well, hopefully any minute now, it will decide to pause and we can do the filament change. But I don't know. Alright, so it did pause, and it did keep the motors locked. They're not moving on me. So now I need to change out the filament. On this printer, it's easiest just to remove this thing entirely. And pull all that out. You can kind of see the print is, you know, pretty sad looking, but that's not the point right now. I actually think that with a 3rd top layer, it would have looked a lot, it would have been fine. Even at this speed, the sidewalls look fine. Let's add this red since it's already up here. Oh, if you end up with a lot of little spools, sample, maybe you've traded somebody, they do make printable little spool holders that you can use. The good thing about the printable ones is that they're usually in 2 pieces, which lets you take them apart instead of having to wrap the filament around there. You just take them apart, put the filament on, and screw them back together. Let's get our red in there. Getting this line overpowers the blue. Okay. Now, let's go over here. Here. And this is what I didn't have before. When I used the M600, I didn't have the resume button, but now I do. So everything looks like it's, actually let's clean off the nozzle. Because I'm getting a little ooze there, and resume. And it went back in place. Looks like everything worked. And it is printing little red dots. And a red border here. So hopefully it will actually work. And we'll have a 2-color little coin. So that, and all of that would work on any regular printer. You don't have to have special anything here. You just need your regular hot end, and you need to have 2 colors of filament or 2 types of filament where you can print one, unload it, use, if the M600 is not working for you, do what I did. And you can't write pause. So you can't just write pause, because pause is a Klipper command. You would have to write a little subroutine here that would do the pausing for you if you were using Marlin. The M600 should work fine though, because that's built into Marlin, so that should be fine. Let's see what we've got going over here. So at least now I know how to make mine work. So, and it sort of worked with the M600, but it was not resuming the way I wanted it to. This was easy enough. You can kind of start to see the two colors happening in there. It is on layer 15 of 20. It says it has another minute to go. Actually, it's weird. The file says it has another minute to go. It's predicting finish in 7 minutes. So, I don't know. It's moving along though. We could try bumping up the speed a little more just to get it done. So in the Klipper, there's a speed button, not a button, but a type in window, and you can just type in a speed that you want to go at, and it will try to do that speed. So now we're at 250% of our base. Our base was 70 millimeters a second. It's doing okay. I might go to 300. And just see if it can keep up with that at some point. So I probably will increase my temperature also, because now as you try to go faster and faster, you have to still deliver your filament. So you have to deliver more and more filament. At some rate, you can't deliver enough filament. So I did bump up the temperature to melt the filament a little bit faster. I was at 200. I moved it to 205 just to try and keep up with the increased flow rate demand. We'll talk about flow rate. You can actually measure your flow rate. So there are some tools that you can use to, if you have a way to measure a small mass or small weight. So you need a tiny scale, but assuming you have that, then there are some tools to help you measure, well, what is my maximum flow rate? So you can kind of start to optimize how fast can you print certain materials. We'll look at that soon. Maybe next week we can do that. I haven't done it for this printer. This one should flow pretty well. It's got the larger diameter nozzle. I can go to hot temperatures if I need to. It's a direct drive, so I can really feed filament accurately. So I think it should be a decently flowing printer. At some point, the input shaping won't be able to account for the vibrations that you're trying to go too fast. It says it's on the last layer. Oh, there it goes. All right. So other than the fact that I tried to go a little too fast, and apparently I did get one little ooze here, maybe one there. It did work. So you get a multicolor part. You can see through it because of the low infill and not many top and bottom layers. But now at least I know how I can get the multicolor to work on here, and you get some pretty cool effects. You do have to plan it out ahead of time to where you're not going to get colors mixed together. Although there is, I'll have to bring that one up. There is a way to get multiple colors on the same layer that looks really cool, but it's way more work to get that to work. But that is possible to do, and we might look at that. There's actually a really good video. I can't remember who made it. I'll have to look and see who made it. But there is actually a really cool way to do that. But this is easy. It's easy to do, and you can get some cool little multicolor parts. All right, we'll be back next week with some new stuff. Maybe we'll do that flow rate calculation. That would be a really cool thing to start to optimize how fast can you print reliably on your printer. And it's not difficult to do. It's a little time consuming, so I'll have to do some of it ahead of time, but it is a pretty good thing to do. Maybe I'll print some of these at a better quality.